Alright guys, this is part 1 of the 3-part gear system tutorial series. In this video, you'll learn how to set up all the bearing mounts for the gears and pulleys you see on screen over here using dimensions, axial locking, and pitch center calculations. Let's get into it. We're going to start by creating our Onshape document. To do that, we're going to go over to the Create tab in the top left, select the Document option, name our document, and select the Create tab in the bottom right. The first step in designing our plate is making a schematic, called a sketch in most platforms. This schematic will dictate the location and sizes of bearing and screw holes, mounting locations, and the overall makeup of the plate itself. To start building up the schematic, we're first going to select the Sketch option in the top left of the center console. We're going to click on the top plane because we want this plate to lay flat on the ground. And finally, we're going to select the top option in the Rotator cube to ensure a level viewing angle. However, before we start sketching, we're going to need to take a look at the manufacturer schematic for the dimensions that we need. For the motor being used for this video, we need 4 M4 screw holes arranged to form a centered 16mm square. Now, what that basically means is that if we took an invisible square that's 16mm long, we would have to put 4 circles with a diameter of 4mm on the corner of the square to properly mount this specific motor. To make this, we're first going to need to create our guiding construction lines, the invisible square that our holes will be aligned with. To do this, we're first going to need to go over to the top left and select Center Point Rectangle from this drop-down menu. Once we do that, we're going to click on the origin, the center black dot that marks the very middle of our parts creations, and drag it out, click it just like so. Now, you may be thinking, well, this isn't very precise, is it? And you're right, it isn't. And to fix that, we're going to need to take advantage of something called the dimensioning tool. What the dimensioning tool basically is it's a feature in Onshape that allows you to influence the radii, side lengths, distances, and angles of all the things you create in the sketch menu. To make use of this tool, we're first going to click on the dimension option in the center console, or as an alternative, you can click D on your keyboard. Next thing we're going to do is click on the length of our created rectangle, change that from 34mm to 60mm, just like so. Next thing we're going to do is also change the height from 9.9mm to 60mm, creating a perfect square for us to base our future designs off. Once we've created this reference square, we do need to still solve the problem of this impacting the physical appearance of our sketch. To solve this issue, we're first going to drag click all 4 sides of the square and then select the construction option, or as it says, click Q on your keyboard. Now what this does is it turns all of those 4 lines into construction lines. These lines won't have a physical impact on the appearance of your sketch, but they're super helpful for things like references and angles and different shapes and positions of different objects that you create. Once we've created our reference square, the next step is to create solid screw holes. How we're going to do that is by first, from this drop-down menu over here, selecting Center Point Circle, and then for all 4 corners of our reference square, select on the corner point and then drag out just like so. Again, this doesn't need to be precise, it just needs to be reasonable so that we can dimension it later on. Once we have all 4 circles down, we're going to need to dimension them so that they properly line up with the M4 screw holes on our motor. To do that, we're first going to select our dimensioning tool and then click on the outer circumference on each of our circles and change them to 4mm. Once we've created our screw holes, we still need to create a center bore to slot in a bearing for our motor shaft. As you can see here on screen, the bearings I'm using have an ID of 14mm, so that's the size of the hole that we're going to need to create. To do this, we need to select once again Center Point Circle from the center console, click on the origin this time, drag it outwards, hit Escape, and then dimension it by again clicking D on your keyboard and setting the center bore to 14mm. Once our motor mount is situated, it's time to move on to the first belt system. It may seem simple, but there is a hidden layer of complexity to it. And this is exactly why. You see, belts aren't made to order. Instead, they're manufactured at a certain set of predetermined pitch lengths, and even though for a system an 80mm belt would be ideal, the closest that WCT offers is 77.5, so that's what we're going to have to go with. We're going to be using the same 14mm bearings to mount our belt system. So once again, create a 14mm circle. However, this time, we're going to need our bearing to be vertically aligned with our motor mount. To accomplish this, we're going to be taking advantage of a tool called Vertical. The Vertical tool, as per its name, aligns 2 points along a vertical axis. To make use of it, we first click on this option in the center console, and then select the 2 points we want to align. In our case, center points of our bearing holes. Now, as you can see here, this second bearing cannot move left or right whatsoever and is instead locked to this invisible line. Now, to finalize the bore location, we're going to need to set the distance between the two bearings. To do this, we're once again going to use the dimension tool, but this time instead between two objects. So how we're going to do that is once again, select the dimension tool in the center console, or again, click D on your keyboard, select it, and this time select the distance between two of the center bearings, and set that as the calculator specified, 77.5 millimeters. The next step in building this gear system is to set up the bearings for the 3:1 gear ratio. This system in particular uses a 75 and 25 tooth gear, and just like belts, gears need precise distances to work together properly. Once again, we're going to be using a 14mm bore hole for our bearings, but this time, we want the bearing to be aligned horizontally rather than vertically to the previous bearing set. To accomplish this, we're going to be using the horizontal tool. Similarly to the vertical tool, it locks an object to one axis of movement, but this time on a horizontal axis rather than a vertical one. To use this tool, what we're first going to do is select the two center points of our bearings, and then just next to the vertical tool, we're going to be selecting the horizontal tool. As it says here, you can also click H on your keyboard as a shortcut. And once again, as you can see, this bearing hole is locked to a horizontal axis and cannot move up or down whatsoever. And just like what we did with the belts, we're going to dimension the distances between the boards to exactly what the calculator says. In this case, 63.58 millimeters. Once our gear setup is complete, we're going to move on to the second belt portion. Unlike the two previous systems, this one is set at a slant, so there are some more tricks we need to learn in order to construct something like this. To start, just as always, we're going to need to create a 14mm bore hole for our bearing. Now, instead of directly dimensioning this bore hole, we're going to make use of our old friend, the construction line. Basically, what we're going to do is create a line, rather than an empty space, between the centers of our two holes. That way, when you escape and try to drag it, they'll always be connected just like this. And now we're just going to dimension the line itself rather than the physical distance. In this case, 65 millimeters. Now, as you can see, when I make adjustments, it's the angle between the two holes that gets affected and not the physical distance. Now, to set that angle to what we want, we're going to once again make use of the dimensioning tool, but this time to manipulate the angle rather than the distance. To do this, we're going to once again select the dimensioning tool, but this time click it between two lines rather than 2 points. So we're going to select the line that we want, and also a flat line that's set at a 0-degree angle, and rather than changing the distance, we're going to change the angle. This time between 42 and 45 degrees. Also, just make sure to turn this line into a construction line so that it doesn't impact the physical appearance of your plate. Alright guys, that's all I have for today's video. So far, we've set up all the bearing and mounting holes for our gear system with dimensioning, vertical and horizontal constraints, and learning how to read manufacturer diagrams. In the next video, you'll learn how to do clearances, billets, and plate lightening, and fully finish constructing the holding plate.